Hello everybody. Today we're gonna talk about one of the most common mistakes in the calculations of the raft on pile. In the beginning, I have to tell you that this tutorial was already presented in Arabic, and now I'm gonna to make it English based on many messages I received from non-Arab speakers because I believe this is a very important video. Let's start. Here we go. Raft on piles. What is the meaning of raft on piles in the beginning? Raft on piles means I have a raft and I have bearing capacity obtained from the soil report, and soil report did not give me the bearing capacity that could sustain the tower without providing piles. Means the bearing capacity is very low, okay, and the stresses from the raft exceed the capacity. And the time I have to provide piles. The pile capacities and the pile lengths and pile whatever, all are provided in soil report. Soil report provide me everything, all information about piles to provide here. Okay, so second step, I have to determine the thickness of the raft based on the selected pile distribution. Suppose we have already finished the pile distribution, okay, and already provided the an estimated the thickness based on flexure and punching of every pile and under each column also as well, and it was safe. Means it is locally safe. Means raft is locally safe under each pile and each pile. But this is not enough. You have to make a further check, which is called the one-way shear of the entire raft. Entire raft means this raft is the entire one under the tower, because the tower already was located upon this area. Okay, this is the distribution of the columns. This is external columns here, all around, and the core in the middle. What about external here? This is for podium. Podium is a soil report gave me good bearing capacity can sustain, but I have to make it a consistent foundation system. Means I have to provide pile caps externally to be in the economical as an economical solution for that. So how to calculate the one-way shear on the raft? The one-way shear, you have first of all to select the proper section to check that. Here, let's go here for this raft. If we go for this section, okay, I have a section here indicating that I have 2-meter raft to the left, then 4.5 meter raft thickness, then around 6.5 meter raft thickness here due to left bed. So I have two sections to check about. This section, which seems safe, but this section seems critical, more critical, this one. So this is the section that I'm gonna start check the raft, the one-way shear on it. How to calculate the one-way shear as a principle? One-way shear means the net force to the left-hand side or the net lift from the right-hand side divided by the width of the section divided by also the depth of the section. This simply you have to calculate the one-way shear that way. So here, what is the width of the section? Width of the section is the width of the raft here, from this line up to this line. This is the width. What is the depth of the raft? Depth of the raft is the thickness minus 0.075 meter, which is 7.5 centimeter cup, plus the CG of the bars, because maybe I have many layers here, so you can calculate the depth up to the center line of the bottom steering reinforcement. Okay, so now we have B times D. This is the denominator of that equation. What about the numerator? Numerator is the net force, the ultimate net force. Net force between the pile summation here. This is 1, 2, 3 times 13 piles means 39 piles here. Okay, with reaction aboard minus summation of the column reactions below 1, 2, 3, 4. So far, nothing, no problem. Why I made this video? I made this video because many people try to calculate this one-way shear due to the envelope. No, this is a big mistake. The big mistake is when you use the envelope to generate this equation or to substitute in this equation, which is a one-way shear equation. Why? Why it is wrong? Why it is wrong to use the envelope? Because envelope, as you know, gives me the maximum bioreaction. Bioreaction here supposed from load combination number 15. Okay, ultimate load combination number 15. And here from the ultimate load combination number 15 or 14. This ultimate load combination number 5, ultimate load combination number 6, and so on. That way it's wrong because this extremely exaggerated summation to make a summation from different load combinations for a certain check. It's not correct. All bioreactions shall be generated from the same load combination. In the same way, the same load combination combinations that I decide to consider is load combination number 15 only, which is wind X plus dead plus live. Suppose wind X in that direction, or wind minus X plus dead plus live. Suppose. Okay, so the same load combination for columns to be considered means all of these piles and columns should be under the umbrella of the same load combination. Then take the sum or take the net and divide by B by D. That's way you get the correct one, the correct value. Okay. Now let's go in deep when we toggle to the save file. Now let's start to work on the save file. The save file here indicates the raft of the tower, which is shown in the red color, in addition to gray color for the thickened raft due to a retaining wall around the tower. Here the podium one, and the podium as shown is supported on pile caps. Okay, the sections that we need to make the one-way shear check about is that section. So I have to select all of these piles to the left on to that section. Okay, now I will deduct the column reactions. It will be done manually afterwards. Okay, so here I selected how many piles? As I told you before, 3 piles here into 13 piles. In the vertical means 39 piles are selected, and I have to export the result to Excel. Why? Because when I make a display show tables this way, first of all, I have to select all column, load combinations. So all load combinations are generated till now. How to select them? Go to node results, then node reaction, then node this way. Okay, for which load cases or which load combinations, I have to select from load combinations. No need for envelope. As I told you, envelope is wrong. Even sales of ultimate. Now I have to work in ultimate. Why ultimate? Because I cannot check the one-way shear. Shear means ultimate force. So ultimate load combination start from here, from UD combination number 1 up to, see how many combinations are more than 60 load combinations. I have to select all of them this way. Go down, then shift with the mouse. I selected all. Then tell him okay. After I finish this, I have to ask to show all of these load combinations. The summation of all forces are shown here or individually for each pile. So it is long. What shall I do then? Afterward, I have directly to export the results or these tables to Excel, because I cannot make whatever I'll do now in the safe platform. I have to make it in a more professional software, which is Excel, which is specialized in generation. Is still in progress of the tables. All tables are generated now. Then I requested the save to export to all tables to Excel. So now let's open Excel sheet. It will be opened automatically now. Okay, directly Excel sheets are generated. Then all the loads load combinations that I select all are called combinations, as you see, from UC1, the UDC1, or up to last one. Okay, so what shall I do now? There is no envelope, as I told you. Let's take them by filter. Filter means I have to select each load combination separately. So I go to filter here, okay, then select filter. Just I select the filter, the arrow of the ball down will start. Here I'll start selection. The select all, make it unselect, unchecked, okay? Then start checking UC1, UDC1, UDC2, and so on, okay? Sure, UDC1 maybe not the one that generates the maximum reaction on this raft. Why? Because if we go back to the safe model here, we know that when the x start from this direction, or when the minus x, if I'm taking specifically, when the minus x going this way, or seismic in the direction of minus x, both make additional reactions to these bytes, okay? Both load combination will be the most critical one. Unlikely, let's check all of them. Maybe one of other combinations give more reactions. As I told you, I have to select the maximum summation of all these bytes. Okay, so start from UC1, UC2, and so on and so on. I have no time to make all this in front of you, but let's start from UC, UDC, con B. So I take it here this way, then I request the Excel to uncheck all, and then check this case, which is number 3, as this UDC 3, suppose. Okay, UDC N number 3, B this way. (3B). I selected that. Here, all other results are filtered out except UDC con 1, B, 3B. I take the summation of all these values here equals, I can ask equal summation of all of these combination loads. So this is summation of the load combination reactions of all bytes in that direction. Okay. Okay. Then let's check another combination, load combination. How can I select the other one? I have to go back to the load combination filter again, unselect all, or this way. Let's check another one, supporting Q. Then this way, I take it, copy here, then paste here, okay, or paste here, okay. Then take the summation of these columns equals summation of all of these values, and so forth, okay. Now I make check only between two cells because I'm explaining only, I'm not going in deep. Okay, you have to make this for all load combination. I know it will take time, but this is the correct work. This is the right way to get the maximum shear on the raft. There is some specific function in the Excel called by pivot table. You may use it to make that. Okay, but now let's consider that we made all load combinations here, and we check that maximum of them. Maximum equals maximum of all of these values here. Suppose all load combinations are arranged here, and I take the maximum, then it requires me that this load combination, which is number 3 Q, is the highest one. So if it's the highest one, I have to go back to the save and check also the column reactions of these load combinations, 1, 2, 3, 4 load column reactions, and deduct their values from the summation. This will be the net shear force of that, of this one-way shear check. I have two ways afterward to get the one-way shear, or to check the one-way shear. Either using the safe itself can give me the shear for this load combinations that I selected. Okay, and then I check using the safe software, or take the summation or the net force and make it manually in another software which is manually. So again, I hereby confirm it to you. No way to use envelope because it gives you wrong estimation for the one-way shear of the raft. Some people make the envelope and the first check. How to do that? Let's check it now. Many engineers try to take the envelope at the first estimation that the raft is safe or not in the one-way shear. How comes? He can take the envelope of these piles, which is wrong as I told you in the beginning, but here may be correct in this guessing or this estimation. or preliminary estimation for that. Why? In case you take the envelope of all of these piles, which means that you take the maximum reaction on this pile and the maximum reaction on that pile and so on, means from load combination number 5, from load combination number 6, from load combination number 7, which is never happened. Okay, it should be from the same load combination. But let's check in this way. Take the envelope of all piles and get the summation. Easy, by safe, you can make this load combinations called envelope, and take the summation of all of these load combinations, and then divide by the B by D. In case the envelope of all piles, of the summation of all piles due to that envelope, make the raft, one-way shear on the raft found safe, no need to make the procedure that explained in the beginning of this video. No need to use the procedure that I made by Excel and so forth. Why? In case the raft is safe under this extremely or exaggerated figure, to take all of this pile load combination individually, okay, means it will be safe under each of the individual load combinations separately, logic-wise. But take care, in case the raft found unsafe under the envelope, this doesn't mean that the raft is unsafe under each load combination individually. Again, I have to conclude my video by this way. In case you have no time to check the one-way shear raft on the raft, you can use the envelope just for guessing if the raft is safe or not in principle. How comes? You can use the summation of the envelope of all of these. You can make load case called envelope for ultimate load combination, then divide the summation of all of these piles minus the summation of the reactions of these 4 columns. This will be the net shear divided by B times D. You can get the shear, one-way shear stress. In case it is safe, okay, excellent. Means the raft is safe under extremely or exaggerated figure. But if unsafe, no, this doesn't mean that the raft is unsafe. You have to follow the Excel way that I explained in the beginning of that video. I wish that this video useful for everybody. In case you have any question, query about this tutorial, please don't hesitate to write down as a comment in under the video. Thank you all. See you later in other video, inshallah.